Hi everyone, a good evening to all. Now we are going to study about the question number 76, that is Bernoulli's principle. So the very first thing is what we have to understand here is what is laminar flow. Laminar flow means when there is a flow, then at one point, at every point, all fluid particles crosses with the same speed. Like here speed is v1 for one particular particle, then same speed must be there for each and every point crossing that point. Now when they reach the other point, the speed may become v2. But each and every particle at this point, they cross with the speed v2. So then that kind of flow we call it as laminar flow. Speed is different at different points. Different at different points. But at every point, all the fluid particles should have same velocity. Such kind of flow, fluid flow, we call it as laminar flow. Now for a laminar streamline incompressible fluid flow, when you consider a non-uniform cross section, now between any 2 points where area is A1 V1 and A2 V2, then A into V remains constant. That is, velocity is inversely proportional to area. That is, A1 V1 equal to A2 V2. As area decreases, speed increases. As area increases, speed decreases. And this equation is called equation of continuity. And for such same flow, when you consider between any 2 points where pressures are P1, P2 and heights are H1, H2, speeds are V1, V2, area is A1, A2, then one equation is A1, V1 equal to A2, V2 and another equation is P1 plus half rho V1 square plus rho GH1 equal to P2 plus half rho V2 square plus rho GH2. That means pressure plus half rho V square, kinetic energy per unit volume plus rho GH, potential energy per unit volume remains constant. This is called Bernoulli's principle, or P by rho G plus V square by 2G plus H remains constant. This is called pressure head. This is called velocity head. This is called gravitational head. So the sum always remains constant. Pressure changes, speed changes, height changes, but the sum remains constant. That is what we call it as Bernoulli's principle. Now, when you consider, suppose there is a container open having the liquid at a height h. Now, when you make a hole at a depth h from the top surface, then the liquid will come out with a speed under root 2gh and it will hit the ground at a distance r. Then the range equal to v into time. So the time is, this height will become h minus h. This is just like projectile motion it will become. So 2 into h minus h by g. Then range will become v is under root 2gh and 2 into h minus h by g equal to 2 into under root h into h minus h. And when you make two holes, one is at a depth h, another is at a height h, then range for both of them is same. So range is same for both holes at same depth and height, where capital H is the total height. Now, this kind of formula base, this is only called, we call it as Torres-Ellis theorem. Torres-Ellis theorem means, see, here the water is coming from this point and it is coming out with a velocity root 2 gh. If you look at the formula, it is just like the water is falling freely under gravity from height h. Then actually it acquires this much of velocity. Even though here water is not falling freely, it is looking like it is falling freely and it is acquiring the same speed as that of free fall body, and that we call it as Torres-Ellis theorem. Now, dynamic lift. Dynamic lift means when you consider the aeroplane wing, so there is a pressure P1, there is a pressure P2, so there is a force. Now, the force, or you can take it like this is P1 F1 and this is P2 F2, and always F2 is greater than F1. Pressure below the wing is greater than pressure above the wing. The design is in such a way that the streamline flow will be higher above the wing and the streamline flow is lesser below the wing. So the pressure is more below the wing, so that there is a resultant force that is called dynamic lift. Now, dynamic lift means force equal to pressure into area. So P2 minus P1 into A. A is the area of the wing. That is what dynamic lift. Dynamic lift means the net force acting on the wings of the aeroplane in upward direction due to the pressure difference created below and above the wing. So that is what we call it as dynamic lift. Now let's see a few examples based on whatever we have studied. The very first thing is, here as shown in the adjoining figure, water squirts horizontally out of two small holes in the side of the cylinder and the two streams strike the ground at the same point. If the hole Q is at a height h above the ground and the level of water stands at h above, then the height of P above the ground level is. See here, as I said, the total height is h and one hole is here and another hole is here and this is h, means this also should be h. Now the height will become capital H minus h, because when two holes made at same depth and same height, then only the range is same. This is h, means this also should be h. Then the height of the first hole from the bottom will become h minus h. And one more thing, next question. A vessel of area of cross section A has liquid to a height h. There is a hole at the bottom of vessel having area of cross section A. The time taken to decrease the level from h1 to h2 will be. See here what we will take it is, when you consider the vessel, see liquid is coming out. Now this is the depth h. Now this liquid will go down. Now this is capital H. Now the hole is at the bottom here. So the hole is at the bottom means the capital H value changes from capital H to 0. Height of the liquid changes from capital H initially to finally 0. But at any instant, let's take like this. See, here liquid is coming. So it is at a height H. So H is changing from H to 0. Or you take it like this is H1, this is H2. Then how do we find the value is, see here, A1 V1 equal to A2 V2. where this area is A and this area is A. So A into, now V1 is velocity, rate of decrease in height, and A2 is this one. Now this is dH by dt equal to A2 is A and V2 is root 2gh. Then if you take the integration, then the time taken to reduce the level from H1 to H2 will become A by A into root 2 by G into root H1 minus root H2. Initial level H1 and the final level H2. To empty the vessel completely, to empty the vessel, then H2 value you have to take 0, H1 value is H. So from initial, final level should become 0. Like that, this you can remember like a general formula. So using the equation of continuity, when you make the equation, then you have to understand is V1 is rate of change in this height. And V2 is, already we found it, the speed of ejection, root 2gh. Then if you make both the equations and if you go for integration, then you will get the relation. Now, this is like a junction rule. At every junction, total incoming flow should be equal to outgoing flow. So incoming should be outgoing means A into V inflow should be equal to A into V outflow. So what I can write is A1 V1 is incoming should be equal to A2 V2 plus A3 V3, like A1 is A, V1 is 3. A2 is A, V2 is 1.5. A3 is 1.5A and V3 we have to find. Just substitute the values. Air is streaming past a horizontal airplane wing such that its speed is 120 meter per second over the upper surface. So upper surface we have taken as V2. Any one thing you take it, V1 or V2. Suppose V1 you have taken. That is 120 meter per second. And 90 meter per second lower. V2 is 90 meter per second. Density of the air is 1.3 kg per meter cube. And wing is 10 meter long and has an average width of 2 meters. So area will become 10 into 2, that is 20 meter square area. The difference of pressure on the two sides of the wing. See, when there is a wing you consider, now above it pressure P1, speed V1 and below P2, V2. So here one more thing, just you have to specify when we have taken the Bernoulli's principle here itself, if we mention better, like in case of horizontal pipe, height is same everywhere, then only P plus half rho V square remains what? Constant. That is what even we applied in case of dynamic lift, the horizontal wing. So wing is horizontal, that's why we will take only pressure and kinetic energy. Height is same everywhere. So that here also same thing when you consider, see, P2 plus half rho V2 square equal to P1 plus half rho V1 square. So that P2 minus P1 equal to half rho into V1 square minus V2 square. Rho given, V1 given, V2 given. Even dynamic lift also when you consider P2 minus P1 into A, that is also equal to half rho into V1 square minus V2 square into area, where V1 is speed below the wing, speed above the wing, and V2 is speed below the wing. Now, one last and final question. A hole is made at the bottom of a tank filled with water. If the total pressure at the bottom of the tank is 3 atmosphere, The total pressure at the bottom of the tank is 3 atmosphere. Now, the height of the liquid filled is, let's take H. Here pressure is P naught. Now here pressure P is P naught plus H rho G, and that is 3 times atmospheric pressure than the liquid. That means H rho G equal to 2 P naught. Now they are asking what? Velocity of a flux. Now hole is made at the bottom. Hole is at the bottom means the speed of a flux will become under root 2gh. Now h value indirectly they have given here. So from here h value is 2 p naught by rho into g, where 2 into atmospheric pressure is 10 power 5 by rho is density of water is 10 power 3 into 10. So that height will become 20 meter. Now if you substitute V equal to under root 2 into 10 into 20, that is root 400. So this way they will ask question based on Bernoulli's principle and its applications like aeroplane, Torricelli's theorem, and speed of a flux and equation of continuity. So please just try to understand the question and compare the Bernoulli's equation or equation of continuity between 2 points. But you have to choose those 2 points wisely. Between which 2 points you can apply Bernoulli's theorem or equation of continuity. Or sometimes the question will be given based on the formula, just like we have seen 1 or 2 examples. So similar examples I have given as an assignment. So please just try to solve, then you will get the idea. Thank you. We'll continue in the coming session with the next question.